Now.
Good afternoon. May I kindly request the professors to take off their caps. I open this session with a prayer. May the spirit of wisdom and mercy grow and blossom in all of us. Please be seated. So, I welcome you to this academic session, especially you. It's on the occasion of your public defense of the thesis towards domain-specific machine translation and quality estimation systems by Javad, Pourmostafa, Roshan, Sharami. The PhD committee consists of, first of all, online Professor Monti from the University of Napoli. Second, Professor Kenny, from Dublin City University. And Professor Teskan from Ghent University, all online. Present here is Dr. Karakanta from the University of Leiden and Professor Ali Shai from Tilburg University. And of course the supervisors are also here. That's the promoter, Professor Spronk, and the co-promoter, Dr. Sterionov. All right. Before we start the defense, I would like to give the PhD candidate the floor to give a concise summary of his research in terms that can be understood by the public. The floor is yours.
Yeah, okay. I hope you're all doing great. I will be presenting the layman's version of my dissertation, which is titled Toward Domain-Specific Machine Translation and Quality Estimation Systems. At first, I would like to lay out a bit of foundation by explaining these two different tasks because I've been working on these two tasks during my PhD. Tell you what they are, how they are defined, and what is the goal in machine translation and quality estimation, and what is needed to create machine translation models and quality estimations. So the goal in machine translation is automatically translating a source text to a target text, for example, Dutch to Farsi, and we want to do this through an engine, and this engine, of course, requires parallel corpus, and parallel corpus comprises of source and target text, and once you do have this parallel corpus, you can train your engine. Hypothetically speaking, if you pass a source text to a machine translation engine, you will get a translated text. Now the question that arises here is, how do we evaluate machine translation performance? Broadly, we can do this in two different ways. The first is reference-based evaluation. So you do have a test or a reference test, which comes from a human, and then you run some automatic metrics such as blue, comet, and you get a discrete value, and this discrete value would tell you that to what extent your translation is good or bad or neutral. The second approach is sometimes you want to do this evaluation without human intervention. So basically, this is where quality estimation comes in, and quality estimation would tell you that to what extent the translation is good or bad. And the thing that I would like to highlight here, for machine translation, I said that we do need a parallel corpus. For quality estimation, we need the triplet input, not only source and machine translation, but also post-editing, which is very scarce, and that makes quality estimation difficult. So there have been a lot of challenges in the field of machine translation and by extension in quality estimation, namely long sentences, word alignment, gender bias, etc. One of them that I would say that remains persistent and annoying is domain mismatch. Basically, domain mismatch refers to the phenomenon where you train your model on one specific topic, and then when you deploy your model on cloud or like on your machine, and then if you pass a different distribution of data, you get this domain mismatch. And if there's two different domains, for example, the one that you see here on the slide, news and medical, do not match, you get the sharp drop performance, which is of course not desirable. With respect to this domain mismatch in my dissertation, I've addressed like some challenges, and I would like to share them with you. The first one is the lack of in-domain data. So we know that data-driven machine translation, including large language models with any fancy like parameter-efficient fine-tuning, require in-domain data. But of course, this data is not available for every single like domain. We do have a lot of data for different language pairs, but for domain, like if we are looking for a specific domain, that's lacking. So in one of our studies, we proposed a data selection algorithm, which basically selects only relevant sentences from large mixed domain data pools. So basically, you have a generic data. We only select those that are relevant to the domain that we want to use machine translation on. And in our experiment, we showed that a small, carefully curated selected data can outperform large mixed domain training. And of course, because you have fewer data instances, you get the same performance as like training your model with a large amount of data, and the broader implication of that would be reducing computation expenses associated with your experiments. What I would like you to remember when you're leaving auditorium is just the smart data selection can replace large-scale training. So instead of dumping a large amount of data to your model, we can just select those that are relevant. And the second challenge, if you remember, I said that QE requires triplet input. So not only we do have the domain mismatch issue in quality estimation, but also we do have this data scarcity issue in quality estimation. And of course, people use quality estimation to provide insight into translation workflows. And if this QE is not working properly, you're getting wrong signals, and you would like to avoid that as much as possible. So the problem here is QE models struggle when a topic or there is a change in domain. And also we do have the issue of data scarcity in domain, like in QE specifically. So what we propose, a gradual adaptation, whereby we first provide some sort of generalizability, and then we synthetically generate in-domain data, and then as a last touch, we provide domain-specific data. As a result of this gradual adaptation, we first attract this, we first brought this to the community, the attention to the community that QE, like machine translation, needs domain adaptation, and also in our experiment, we showed that this gradual adaptation leads to improvement in QE system, specifically for low resource languages and many unseen languages, which is very scarce. So the takeaway here is without domain awareness, QE can be misleading, expensive, because if you get the wrong signals, basically you're passing some sentences which are already good and not needed to be post-edited. This is something that I would like to highlight here. And now we are going a bit lower to the like a lower level. Now, so far I've been talking about like data scarcity, domain mismatch, but assume that you have a machine translation model or QE, and then you are dealing with a new data set. This new data set brings in new vocabularies, new tokens, and if they're not taken into account, the tokenizer, which is part of your deep neural network, cannot segment them properly or segment them poorly. And of course, just to like make it like a layman thought, neural models, of course, do not understand textual information, and this information should be converted to numerical values. And this is what tokenizer does. So in one of our studies, we systematically analyzed, given a machine translation and a fine-tuned data set, where should the data come from to train a tokenizer. Specifically, I'm talking about the smaller neural machine translation models, not large language models, which share a large amount of tokens. As a result of this study, we provided practical guidelines which machine translation practitioners can use when they're dealing with the smaller neural machine translation models. And takeaway here is just careful tokenizer design improves the translation quality and reduce costs if they're taken into account. Okay. And the other study that we conducted was about in-context learning. So nowadays, everybody uses large language models, and large language models, of course, can be fine-tuned, but sometimes you can use some in-context examples or prompts to fine-tune them. Basically, you need to find some in-context examples that match the domain and the style of the sentence that you want to be translated in machine translation. There are several issues here. One of them is just there is no universal prompt template for every single large language models. And other issue is the fact that ultimately if you translate something with large language models, that depends on human judgment or reference set. So what we did, we adopted one of our domain-specific QE models that we proposed in one of our prior studies. And this domain-specific QE guided search only tell us which in-context examples can be chosen from a set of examples, and those in-context examples lead to increase in the translation performance. And as a result of this domain-specific QE, which provides this reference-free setup, we can select most impactful examples. And in our experiment also we showed that we get higher performance with fewer and high quality examples. And of course, if you have fewer in context examples, that leads to faster inference because you're dealing with fewer tokens, and you will have more consistent translation. And we know that large language models tend to over-generate, and as a result of this QE guided search, we found that we could have reduced post-editing effort, which is very important when it comes to translation. Takeaway here is quality aware in context selection enables domain adaptation, and that doesn't require fine-tuning. So I would like to kind of rehash the insight that I've already talked. Out of all of the PhD defenses that I've attended so far, I barely remember what they did. So hopefully in 5 years you will remember what I've done. So smart data selection replaced large scale training. So instead of dumping large amount of data, it's better to just select those that are relevant to that domain that you want to work on. Domain adaptive QE improves reliability, and that's really important in QE, and also it can improve the performance for many different language pairs and low resource languages. And tokenization is really important, especially if you're working on a small neural machine translation models, and that improves the performance. And QE guided in-context learning enables domain-specific machine translation LLMs. And of course, I would like to advertise my book. You can find it on bold.com, but OP is up, so please act quickly, otherwise it will be out of stock.
Okay, thank you very much. That was perfectly clear. I believe you have a statement to make.
Yeah, sure. I hereby declare that this thesis is my own work, and that during my PhD program I operated according to the principles of scientific integrity, honesty, and scrupulousness, critical attitude, and transparency, independence, and impartiality.
Perfect. Yeah. Thank you very much. Then we move to the defense part of this event, and you will get some questions from the committee members, starting with Professor Monti from Napoli. The floor is yours.
So good evening, everyone. So I have a few questions for the esteemed candidate. Just a second, I have to switch off again. Okay. So the first question. So the first question concerns chapter 2 and is about the methodological risks of automatically selecting in-domain data from generic corpora. So what is your opinion about this? I don't know if I have a few more questions. Do I have to?
Did you get it?
Sorry, is it the question, highly esteemed opponent, thanks for your question. I was wondering that if you can clarify in the question, is it a question about the methodology? Is there anything specific about the methodology, or like generally you want me to explain about the methodology?
More about the methodological risks, yes.
Yeah, okay. So basically, so what we did, we started with the generic data set, and we used we first converted all of the sentences in our data set, both generic and in domain, and then we turned them to embedding vectors. We used some dimensionality reduction techniques to reduce the embedding vectors. And one of the risks here, for example, because I condensed the vector to the fever dimension. Originally it was, I think that if I remember correctly, it was 1024 dimensions. So here there might be some loss with respect to dimensionality reduction. And moving forward after dimensionality reduction, we went to using this cosine similarity to select from out of domain dataset using in domain dataset. Here, of course, we used static n to only choose 5 different samples per inquiry per query. Sorry, and given that we chose 5 different sentences, there might be, for some example, you don't find relevant examples, then the sentences that you select might not be exactly resembling the query that you are looking for. These are the risks that I can think about.
Mm-hmm. Okay, so and how would you, let's say, think about reducing these risks by, let's say, human evaluation or what other?
Yeah, in terms of reducing risk, I would consider first regarding the dimensionality reduction. Of course, we can go with the higher dimension, but that requires more computational resources to load the data into the memory. That was actually the main reason that I didn't opt for. And with respect to number of n, the static one that we chose, I think that we can go with the dynamic n in order to just if we see below a certain threshold and we are going to get, I don't know, 60, 70 or it's going to 50, then we can perhaps stop selecting more examples from one specific query, but that would fall under hyperparameter optimization. This is actually, I didn't want to do it. And if I understood correctly, you mentioned that human evaluation, or I missed it?
Yes, human evaluation.
Yeah, I think that that's actually, it's a good way of kind of validating or strengthening the validity of experiments. One of the problems that I had at the time of running experiment was the number of the system that I had to compare with each other. If I wanted to go with human evaluation there, perhaps we would need a lot of annotators to annotate the sentences if we want to go for a certain translation dimension. But I don't negate the importance and significance of human evaluation. Just at the time of running experiment, that was not an option, but definitely that can be considered.
Mm-hmm. Okay, so another question. So it's about subword tokenization. So in your opinion, could your subword tokenization strategy for fine-tuning neural machine translation that is optimal for one domain be suboptimal for another?
With respect to subword tokenization, it's very difficult to find an optimal number, and then ultimately that depends on the data set that we use. This is a very good question, I think, and I also received the same question in a conference. That would be really difficult to exactly go for one specific vocabulary overlap in terms of the number and say that whether that's a number that can be, for example, publicized as a vocabulary share with respect to pre-trained and fine-tuned data set. I think that goes case by case, and there is no a universal vocabulary number there.
Okay, so thank you. I think I have some time for a last question.
Yes, you have time for one more question.
Okay, so you said that your approach produces translations that are more length-aligned with human references. And how do you interpret length alignment as an indicator of translation quality? Is this alignment, does this alignment reflect, in your opinion, genuine adequacy and fluency improvements?
Yeah, well, with respect to if this is whether this translation aligned with human interpretation. For example, in one of our chapters, in chapter I think that 5, if I'm correct, we provided a QE model which was trained on a training data set, and we used that training set. Hopefully that training set is not really deterministic, and it provides some sort of generalizability. And we didn't really gauge the exact the number of whether that would indicate any alignment with the human preference, but we provided some metrics such as blue, comet, and they're not really provided in isolation. We provided a bunch of them. And if, for example, if you're looking for retaining the lexical similarity in the sentence, perhaps that blue could just provide that fluency in the sentence, but there was no exact indication of a human alignment. There were some learned models, and those learned models just learned the association from the training data, but there was no exact human evaluation conducted to do so. I mean, that being said, in one of my collaborations with the industry, there were some experts and a human annotator. We used their expertise to use post-edited text that was coming from humans or experts in those domains. And generally in domain-specific machine translation, because we are not dealing with generic sentences, we are dealing with specialized text, finding human annotator who are specialized in those domains is very difficult.
Okay, thank you. So I would like to conclude with my congratulations to your excellent dissertation. And I really appreciated how you organized and also how you addressed all the research questions and your methodology and results. So thank you for your work.
Highly esteemed opponent. Thanks for the compliment.
Thank you very much. Then the opposition will be continued by Professor Kenny from Dublin City University. The floor is yours.
Hello, esteemed candidate. I'd like to echo the comments just made by Professor Monti to congratulate you on a really interesting and important thesis. I'm in translation studies rather than computational linguistics, strictly speaking, and I can see that you've made an important contribution to my area as well for various reasons, especially your focus on sustainability and the environmental impact of research, and also obviously implementing certain workflows in industry. So thank you for that. The first thing I'm going to do, though, is ask you about the rather tricky concept of domain. I have a feeling that in your thesis you're juggling with the two quite different meanings of domain. One meaning provenance, which is your kind of preferred or your prioritized meaning, and the other meaning something to do with topic, etc. And I'm just wondering, how much of a struggle or a challenge did you face, because the term and maybe the concept of domain is so vague in some ways? Yeah,
highly esteemed opponent, thanks for your question. Also, thanks for your compliment. Indeed, that was really challenging to figure out whether I should go with the provenance-based domain-specific machine translation, especially when it comes to evaluation, or versus topic-based domain-specific machine translation evaluation. And the main reason is I opted for provenance-based domain adaptation was reproducibility, because if we wanted to go for the topic-based domain-specific machine translation, we would have this subjectivity issue. And specifically, like, you know better than me that in like topics, we do have like subtopics and all of them are correct. Like a good example would be IT and network. At least I see them as like some sort of overlap. And if I give one specific sentence to like two different human annotators, they might end up labeling them completely differently, but also they're both correct. Like, for example, I might say that this is network and someone else would say that this is IT. And there, just that would be really subjective. And we do have a lot of examples of this issue when we want to go with the topic-based domain-specific machine translation. Whereas if we want to go for provenance, and actually I think that this is in my opinion, this is the best way of, at least in terms of interpretability and explaining exactly what like might go wrong in like, for example, when you train a system, if I tell someone, if I shout in the machine translation conference, say that this is WMT quality estimation shared task and give them a label, and if I say that, oh, this system went south because of this label, they would know exactly which data set, which system, and they would have a lot of information. Whereas if we wanted to go with the topic, then we would need the human annotator, we would need more like precise and very well-defined definition of the domain, which also that's fine. I mean, if someone wants to go for the fine-grained analysis, that's also encouraged and recommended. But then that would, for example, if we want to have topic-based domain-specific evaluation, we do have some frameworks such as MQM, direct assessment, and they require, like, if we wanted to follow their protocols for direct assessment, at least there needs to be, like, if I'm correct, 10 to 15 human annotators to do this properly. For MQM, that requires, like, we don't need 10 or 15 annotators, but we do need to train them extensively. As you said, there was a struggle indeed, and I opted for the provenance mainly because of like reproducibility and wanted my experiment to be like replicated by others.
Okay, and just as a follow-on question to that, you say something really interesting when you first of all defend the provenance understanding of domain. You say that domain adaptation depends more on vocabulary, phrasing and style rather than any kind of conceptual topic match. So these ideas, vocabulary, phrasing, style, strike me as they're internal criteria. They're internal to the corpus on which you train systems. Are you making an assumption that there's a kind of consistency in these features of texts? Or is this based on some empirical work that precedes your work?
Yeah, well, of course, I haven't done any experiment to like kind of prove the point that whether that's based on like empirical evaluation or not, but that's something that comes from the literature. And like when I was talking about the topic base, also within the topic, when you evaluate a sentence or annotate a sentence, they might have a different form or styles. I think that that's more like conceptually defined for the readers to have a better understanding of domain adaptation, because all of this like nuances should be somehow converted to numerical values, and they come from the parallel corpus, which is which is our like gold standard way of training these models. So I see this collectively as a like all together just would affect the like a domain as a whole. But I haven't done any empirical evaluation, and I see your point.
Yeah, it's an interesting kind of topic. It reminds me of debates about representativeness in corpus design, whether it's internal or externally determined, if you like. I've another quite broad question, and that's about the comments you make about in-context learning, where you talk about it being more flexible, scalable, data efficient than other approaches. And so this really brings up the question of the future. Should future research concentrate on large language models and in-context learning? Is it over for conventional NT and other ways of doing things? What are your views on that?
Yeah, highly esteemed opponent. Thanks for your question. So I think that this is two different perspectives. If we want to go with large language models, of course, we have to take a couple of things into consideration. For example, the cost to build these models. So of course, people use a lot of computational resources to train these models, and then they're of course multitask. They're meant to be generic, and I think that I do know that from working with some LSPs, or at least talking with people, I do know that they're currently using large language models, but also they're just fine-tuning them by having the translation memory, having some sort of some techniques such as fuzzy matches to kind of strengthen the performance of these systems. But if there is no need for this huge investment, and you can get the job done with the smaller neural machine translation models, I think that personally that's a better choice, especially with respect to sustainability. If you know already what domain you're working on, and let's say that you're working in patent and chemical data, actually that was one of the two domains that I worked with the company, and they already knew that these are the domains. They're just they have some frequent customer client, and then basically based on those domains they had some data, post-edited data, and then trained the models. And in terms of number of the parameters, or that also connects to the computational resources required for deploying these models, I think that I would go personally with smaller models, fewer parameters. But I mean, we are in the hype of large language models, and there is this always thinking that, okay, now we do have generic models, how we can make them specific. And also recent studies have shown that large language models are lacking when it comes to domain-specific machine translation. So again, we are just making them more fine-tuned, which is costly, of course. So in my opinion, in my eyes, I think that a smaller neural machine translation are the better choice.
Are you satisfied with these answers? Are you satisfied with these answers? Yeah?
Absolutely. Thank you.
Great. Thank you very much. Then we move on with the next question asker, which is Dr. Teskan from the University of Ghent. The floor is yours.
Dear esteemed candidates, first of all, I would also like to congratulate you on this valuable and carefully executed thesis. So your thesis addresses a really relevant challenge in machine translation and quality estimation, namely domain mismatch and domain adaptation, and it does it from several very complementary perspectives. So I really particularly appreciated the coherence across the different papers in your thesis, which together form, to me, a clear and well-motivated research trajectory. So thank you again for your work. I would like to start with a quick question, which has already been discussed actually, and also asked by Professor Kenny in a way, and which is about the definition of domain and provenance and topic-based definitions. What I would like to particularly ask at this on this subject is that at some point in your thesis you argue that the topic-based definition introduced some stylistic and structural ambiguities, since topic labels can be subjective and heterogeneous, and you give the example of a medical dataset which can consist of different types of documents, as you mentioned, ranging from clinical reports to public health texts, etc., which in return also leads to a less stable linguistic basis, maybe compared to the provenance based data set, which I also agree with. But my first question is regarding this is, regarding some of the data sets that I use, like the IWSLT 2014 or the WMT 2021, which you already mentioned that these data sets are easily recognized by the audience of or researchers in this field. But as far as I could see, the IWSLT dataset consists of TED Talks, whereas the WMT dataset consists of Wikipedia and Reddit articles. So I was wondering, given these kind of resources, as far as I can understand, these datasets contain multiple topics. First of all, do you know so? And if you think that they contain multiple topics, aren't you actually introducing maybe a broader challenge of preserving these linguistic properties you were looking for?
Highly esteemed opponent, thanks for your question, and also thanks for your compliments. It's completely true that, for example, IWSLT, WMT quality estimation data set consists of different topics and different like styles, form, and different phenomena. I completely agree with that. And this is actually one of the reasons that we opt for provenance-based evaluation, because that would basically then that would be the representation of the data set. And therefore, we could use that when we wanted to interpret our results, and we wouldn't really go for like more fine-grained analysis, which that also requires some human like annotators, human evaluations to kind of like dissect exactly which part was translated perfectly or which part was partially translated. And so basically the provenance base, as I told previously, provides reproducibility, and that one of the challenges that I faced during like setting up my experiments, and I agree that that could have been like perhaps separated, and then from there we could just have more fine-grained analysis. That being said, for example, I now working with like aviation company, and we do have some mechanics. They do have some like terms. They are willing to just annotate the data set. And that also would be really subjective. You would need a data set with which comes from some like annotators, and if you also train models and say that this is the like a topic or a domain that I'm working on, someone else might disagree with that topic. So we do have this issue of like polymorphism in domains that I think that the best thing that I could like figure out from reading the literature is just going with the provenance base, because that would kind of like represent the data distribution. But I also see that from more linguistic point of view, it would be better to just focus more on like a different phenomenon of like style, form, register, and etc. One of the things that I also came across when running experiment was the fact that modeling these linguistic features was really difficult. And yeah, I don't know if I answer your question, but if something remains unclear, please let me know.
Yes, thank you very much. Yes, and maybe just a quick follow-up, because it seems like a practical problem rather than maybe a conceptual one. So I'm wondering, if you had no financial challenges, how would you come up with a proper data set for your research in this context?
I think that actually that was one of the challenges, like not having enough resources, but also that would be really like time constraint, I would say. But I would just perhaps have a clear guideline for annotators, just like give them a questionnaire, give them the sense of that what domain I want to be labeled as domain, and give them kind of a structure, kind of like an instruction to like label this like sentences, and from there I proceed with like the rest of the pipeline. Yeah, as I said, now working with the aviation company, there are some mechanics. They do have like understanding sense of the like a aviation topic domain, and then they could just label those terms. But yeah, maybe if we change the like aviation company from X to Y, I don't want to drop the name, but then they might also disagree with the domains that were labeled or the sentences that were labeled. So that would be also problematic.
I understand. Yeah, thank you for your answer. So my next question is rather about evaluation of translation quality, and specifically chapters 2 and 4. We know from some previous research that lexical metrics and neural metrics do not always align or agree when assessing performance improvements, especially in domain-specific settings. So lexical metrics sometimes indicate performance gains, potentially due to improved terminology, consistency, or lexical choices, whereas neural metrics may not reflect the same level of improvement, maybe on overall semantic level. So regarding chapter 2 and 4, your evaluation relies primarily on lexical metrics such as BLEU, TED, and CHRF. And considering that maybe a lack of neural metrics in these studies, do you think, or how do you think the inclusion of such metrics, semantically oriented metrics, might have affected your results? And let's say if COMET did not agree with the best system you have found so far with BLEU, how should we interpret your results or their generalizability?
Yeah. Hi, Lisa Poland. Thanks for your question. Indeed, that was the issue. When I conducted chapter 2, it was 2021. That time, COMET was not released, and there was not a hype about COMET and neural-based metrics. And actually, another issue that I do have with COMET, and also has been shown in the studies, that when COMET is neural-based, and also we do have also the domain mismatch problem in COMET. So one should first train COMET on the training data, and that for that you need the gold standard, and then again you use the COMET. And from that point of view, COMET can be also misleading. And another reason that I opted for lexical-based metrics for chapter 2 was this direct comparison with the prior work, especially the 4 benchmarks that we had. So that was one of the reasons. But I also, with respect to tokenization, there also I use BLEU, but I try to provide other metrics in addition to BLEU. But yeah, I agree. The rest also were lexical, but I was thinking that provide more comprehensive results, and people can see it from different directions. But that can be seen as things that I can do to strengthen the validity and the evaluation of the experiments, and definitely I will do.
Yes, I agree with your motivation, but also just very practical. I'm aware that COMET maybe did not exist at that time, but let's say now you repeated your experiment and suddenly COMET showed a better other model than the BLEU metric. How would you approach to this difference? Would you maybe prefer BLEU as still a primary metric for domain-specific cases, or would you suddenly switch to say that COMET, because this being a more recent and neural metric, that maybe provides more interesting information?
Yeah.
Briefly.
Yeah, sure. We'll keep it short. I think that ultimately that depends on the translation goal, right? If I want to retain the lexical overlap between my translation and the reference, then I would go with the BLEU. If I wanted to keep the contextual, I want to preserve the contextual signals in my translation, then I will go with the COMET. So ultimately it depends on the goal in translation. Is it whether it is dissemination, assimilation, or I would look at the task and where the machine translation is going to be deployed, and based on that, I will make a decision.
Okay, thank you.
Okay,
are you satisfied with
very
this?
much for your answers?
Yeah. Okay, great. The discussion will be continued by Dr. Karakanta from Leiden University.
Esteemed candidate, I would also like to congratulate you on your very fine work. It's very nice that you approach domain adaptation not just as a machine translation problem, but you also incorporated quality estimation in this. Also an aspect that is worth mentioning is that you also kept an outlook on practical aspects such as sustainability. So my question is about chapter 3, so domain adaptation in QE. So here your reference metric is TER, or HTER, as you meant. But, so this was based on data and experiments in 2021, if I'm not mistaken. So quality estimation has moved since to predict different things. So to move away from just predicting a sentence level score that correlates somehow with the post-editing effort to outputs that are more informative, for example, fine-grained error annotation, and also incorporating generation, so automatic post-editing based on this quality prediction. So based on these developments, I would like to ask you how much your contribution on domain-adapted quality estimation is bound by these experiments that you did, by this paradigm, and what adjustments would be required to move to fine-grained prediction and generation?
Yeah, highly esteemed opponent, thanks for your question. Also, thanks for your compliments. Indeed, that's correct that we are experiencing this shift from TER to direct assessment, MQM, and other metrics. And the time that I experimented, that was kind of like more prevalent, and this is why I opted for TER, but also in the conference I also got the same review that like direct assessment, for example, can be used. So that's correct. I think that in terms of contribution, we, for the first time, as far as I'm concerned, we brought this attention to the QE. The QE also should be adapted to the domain that you're working. And like part of the pipeline, which also provides this generalizability, can be reused specifically like with respect to cross-lingual inference. We did have some contribution that can be reused. And I think that just is a matter of changing the target label and then basically redoing the whole pipeline, and that would work. And with respect to error annotation, that kind of like also links to human annotation and doing more fine-grained analysis, which I agree. I mean, I think that that's something that I'm aware of, I'm fully aware of, that's lacking, and definitely I'm just looking to improve that in the future work. Yeah, did I answer all? Yeah, and with respect to synthetically generating data, as I said in the layman's talk, we do have this issue of generating synthetic data for QE. We do have this issue of generalizability in QE, and therefore we had to synthetically generate data. And I'm not sure that whether for the direct assessment MQM that's possible, and I think that mainly that's not possible to like reuse those parts for other metrics, because this metrics, direct assessment, MQM specifically, they're very granular like annotations, and finding a data set to kind of like get the ball rolling and start from there would be really difficult. But these are the challenges now we are facing in QE. Did I answer? Yeah.
Thank you. So you mentioned you have this pipeline with synthetic data. So the pipeline you propose is quite complex, right? You get a lot of data, you have to machine translate, you combine them. And at some point also in your thesis you make the argument that we should be moving away from model-centric approaches to data-centric approaches. So given also the recent success of in-context learning and prompting and zero-shot approaches, I would like to hear a comment about whether the complexity of your approach can justify, whether the gains coming from your approach can justify the complexity overhead.
Yeah, highly esteemed opponent, thanks for your question. For example, with respect to in-context learning, we do have domain-specific QE. That domain-specific QE, again, I think that's something that I explained previously, was the fact that in translation, I mean, if we want to use machine translation for daily translation, of course, I mean, they're performing really well, but when it comes to like a specialized domain, they're lacking. So I think the people who use machine translation with QE, they're working in very, very specialized context. So they already know the domain that they're working on. Like, for example, they know that they're working in chemical domain. So the QE would be trained once, and that can be reused like I don't know, n time. And actually we did this. We provided a machine translation quality assessment tool, and we got the data from translation company, and then they could just reuse the data for like many times. So there is overhead, but you do this once and then you can reuse it many times. Of course, with respect to in-context learning, In part of our experiment, we showed that we do have this MBART, for example, training from scratch, and also like in context learning, we showed there in terms of contextual evaluation that that would outperform in context learning. So there are some overheads, I agree, but usually in translation, you're working in fixed domains. So most part of the pipeline, I mean, if we move from analysis-based studies to like deploying those, I think the most part of the pipeline can be reused, especially like, for example, with data selection in chapter 2. Like I think that even also is relevant to current like theme in large language model. Those data can be used for like in context, in the format of in context examples if you select the relevant data. And this is actually we did for the in context learning. We adopted some of the like a method that we use in chapter 2, and then we brought them to like in context learning format, and that was effective.
You have time for one short follow-up question if you want to.
Yeah, so in industry, so again, coming a bit back to the question of domain. So you mentioned now that, okay, maybe the chemical domain, you train one model, you have, the company has it. But yeah, in real life, companies, LSPs, often work with different clients, which might have their own terminology, their own style, their own guidelines, different audiences. But there might also be a large overlap among all these clients. So on the one hand, you have client-specific requirements. On the other hand, you have similarity in terms of topics, in terms of term, in terms of the requirements. So how would you incorporate all of these aspects in your definition of domain? Isn't this a bit restricting if you think of real-life usage of QE and MT?
Yeah, thanks for your question, highly esteemed opponent. It is like it's a critical issue that like LSPs are facing, and I think that the solution, like at least one of the potential solutions, as far as I'm concerned, is just dumping the similar or overlap terminologies and some sort of like translation memories, and those terms and terminologies that are frequently used can be again used in the translation workflows. So if, for example, if before giving sentences to post editors, you do have a dictionary, basically a glossary of words which have been previously translated, and you do have the consent of like post editors that they have been translated correctly, and then you can use those corrected translation again without like even doing any processing. So I think that's a possible solution when it comes to overlap between terminologies. Another thing that can be practically done when it comes to large language models is just like as part of the like prompt or in context examples, this glossary can be inserted somehow, and then we can just like fine-tune the model.
Okay, thank you. Are you satisfied with these answers? Yeah, okay, great. Then the defense or the questioning will be continued by Professor Ali Shai from our university.
Esteemed candidate, thank you very much for your contribution to the field. I very much enjoyed reading your thesis as someone who is not an expert in machine translation. I was very impressed by the clarity and by the breadth of the issues that you have covered in your thesis. I want to ask a question about Chapter 2, which is a particularly potentially impactful set of studies on how to make machine translation models more data efficient and less hungry. This is obviously, as we all know, a very critical, important point. And you do show that your methodology can actually lead to the same level of performance with much smaller data set if it is curated in a smart way. Your studies were conducted a few years ago, and as we all know, this is a fast-moving field. I was wondering to what extent your methodology can be generalized to the state-of-the-art models that are now from slightly different families, but perhaps even more relevantly to architectural variations that are aiming at data efficiency, such as sparse attention or mixture of experts. Do you think that you can use the same kind of experimental setup and approach to investigate new families of models? If not, do you need some revisions? In general, what I am curious is whether, not exactly what the outcome of the experiments are, but whether you can actually turn your attempt to a recipe or to a set of guidelines for model developers.
Yeah. Highly esteemed opponent, thanks for your question. So with respect to generalization, I think that what we also tried to do at that time was proposing a methodology that would be model agnostic and also language agnostic. And given the fact that we are using this multilingual model, so we were thinking that, okay, now every languages can be used for this particular like pipeline, and also given the fact that and actually, I mean, one idea when you want to do the data selection is just using the embedding vectors of that like particular model that you're training your machine translation with. So what we did, we kind of like deviated from this approach, and we provided completely like model agnostic approach, which can be reused completely separately in isolation, and those information can be fed to any large language models in the format of in-context learning, in the format of like fine-tuning. If you just create a data set, a small data set, and go with like PEFT and parameter efficient fine-tuning and other techniques. So in terms of generalizability, I think that like the data selection algorithm that we have, and which I'm really happy about, is the fact that it's very like generalizable. And yeah, I think that from that point of view, that's very like also language agnostic. We experimented, I think that for the Sign-On project, we do have this Sign-On project. I also experimented with the Catalan language, which completely deviated from the language that we used in our dissertation. So I would say that even with the current theme, with the current hype, it's applicable, and we can reuse the model.
Shall I continue? Thanks, this is very promising to hear. You actually mentioned language agnostic procedures. I understand that it's in theory, your method might be language agnostic, but in practice, it might work much better for certain language pairs, especially if you are working with multilingual models, right?
Yeah.
Due to different degrees
exactly.
of transfer learning. If that's the case, and so I am curious to hear about your more informed domain knowledge. Would a completely language agnostic method actually worth the effort, or perhaps we should take into account some more linguistically informed data curation method?
Yeah, that's a great, I think that the problem with the more linguistically informed models, at least the things that I have experimented with my limited linguistic like information, because I'm more into model-driven studies, is the fact that when you have some independent variables and also dependent variables, I've experimented with a lot of like lexical linguistic features. You get some signals, like for example, if you're working with the number of the like verbs, subject, pronoun, lexical, like intrinsic linguistic features. When you want to model them, that's completely different things, because you don't get this performance from what you get as a correlation. And then when you want to map it and train it, model it, you won't get that great signal that you want in terms of performance. I think that for certain languages, of course, specifically low resource languages, perhaps we should have like a specific model. And it's very difficult to have a model that can be like a super duper, like multilingual. I mean, even though with the cross-lingual inference advantage that we have, that's to some extent possible, but still having a very comprehensive and wholesome model may be not really feasible to do or to make. So that's my opinion.
Thank you very much.
Thank you.
That's interesting. Do you have a follow-up question, or? Okay. Then we're going to start with a second round for a very short time, I think. So I'd like to ask whether Professor Monti from Naples, do you have a question that you would like to ask?
Oh, yes, I have another question. So, in your view, to what extent are the results of
Okay, I'm really sorry, Professor Monti, but this is the end of the 45 minutes, so we have to stop. Yeah, I'm going to adjourn this session. Please await the committee's return. Thank you very much. Dear candidate, the doctorate board of Tilburg University has taken note of your dissertation. Having heard your defense, the doctorate board has decided to confer on you the doctoral degree. Professor Spronk is authorized to invest you with this dignity.
It gives me great pleasure to accept the task assigned to me by the Rector Magnificus of the University. By virtue of the authority granted to us by the law and by the regulations of the University, in accordance with the decision by the Doctorate Board of Tilburg University, I hereby promote you, Javad Pourmostafa Roshan Sharami, to doctor. You acquire hereby all the rights that by law or custom are or will be attached to the doctorate. Man.
Mine was on.
Yours was on, so it's probably fine. Apart from rights, a doctorate also comes with obligations. These, first of all, include the execution of research and all other scholarly activities with the utmost integrity. The privilege of being a doctor also entails that society needs to be able to rely on the sound and independent judgment of those holding a doctorate. Do you promise to act according to the principles of scientific integrity in future scientific research?
I promise.
As proof of you having been awarded the title of doctor, I hand you the certificate signed by the Rector Magnificus and the supervisors and confirmed with the university's seal of approval.
Thank you.
I perform a pleasant task, learned sir, in congratulating you on behalf of Tilburg University